Hello students, welcome back to Future Foundation. Students, in today's class of vectors, we will learn the concept of skew lines and distance between them. Also, we will see what are parallelepiped and tetrahedrons. So let's begin. Students, first of all, write down the heading, distance between skew lines. What are skew lines? Lines which are neither intersecting nor parallel are called skew lines. So in this, we can write the definition of skew lines. Lines which are neither intersecting nor parallel are called skew lines. This case is only possible in 3D because in 2D lines are either intersecting or parallel. So we have to find the distance between skew lines in this case. So let's say L1 is R vector is equal to E1 vector plus lambda times B1 vector, and L2 is R vector is equal to E2 vector plus mu times B2 vector. Then shortest distance or distance between these skew lines is equal to mod of E1 minus E2 dot B1 cross B2 upon modulus of B1 cross B2, where B1 is the vector parallel to the line L1 and B2 is the vector parallel to the line L2, and A1, A2 are the position vectors of the points through which line L1 and L2 are passing. Let's say this is L1 and this is L2, and this is shortest distance. Now we have to see its proof. That is proof for shortest distance between skew lines. For this, let us consider a parallelepiped. Say ABCDEFGH is a parallelepiped. In this, line EF and GH, in this EF and GA are skew lines. So in figure we can see the shortest distances along GF, or in this case shortest distance is GF. But uh, by definition of shortest distance, we can say shortest distance is projection of EA or AE along GF, and which is nothing but AE cos theta, right? Theta is the angle between AE vector and GF vector. So we can say, or we can write AE is nothing but mod of AE vector, and cos theta is nothing but AE vector dot vector perpendicular to GA and EF. For the time being it is a n vector by mod of E vector into mod of n vector. Now it will become AE. So let us write equation of GA is R vector is equal to E1 vector plus lambda times P1 vector, and equation for FE is R vector is equal to E2 vector plus mu times B2 vector. Okay, say this is E2 vector, position vector of point E, sorry, and E1 vector is nothing but position vector of point A, right? So I can write EE vector as E2 minus E1 dot n vector. N vector is perpendicular to GA vector and FG vector, which is cross product of P1 cross P2 upon mod of P1 cross P2. As distance is always non-negative, so we have to take mod in all cases. So this will become this. So this is nothing but shortest distance. Now let us take an example. Question is, find the shortest distance between L1 R vector is equal to 1 minus t times I cap plus t minus 2 j cap plus 3 minus 2t k cap, and L2 is R vector is equal to s plus 1 I cap plus 2s minus 1 j cap minus 2s plus 1 k cap. So in the given question, equation of line is written in mixed form. We have to write equation in standard form, that is E1 vector plus lambda times V1 vector type. So L1 can be written as I cap as R vector is equal to I cap minus 2j cap minus plus 3k cap plus t times minus I cap minus 2j cap minus 2k cap. Similarly, this is not L2, this is L1, and L2 can be written as R vector is equal to I cap minus j cap minus k cap plus s times I cap plus 2j cap minus 2k cap. Okay, so this is P1 vector, this is P2 vector, this is C1 vector, and this is P2 vector. So I have to use formula for shortest distance, which is E2 minus E1 dot P1 cross P2 on modulus of P1 cross P2. Okay, so first of all I have to find B1 cross P2. So B1 cross P2 is determinant of I, J, K, and B1 is minus 1, minus 2, minus 2, minus 1. sorry, not minus 2, this is 2, minus 1, 2, minus 2, minus 1, sorry, this is only 1, minus 1, 1, minus 2, and B2 is 1, 2, minus 2, 1, 2, minus 2. So this will be I cap times minus 2 plus 4 minus j cap times 2 plus 2 plus k cap times minus 2 minus 1, which is 2 I cap minus 4 j cap minus 3 k cap. Therefore, shortest distance will be E2 minus E1, which is 0, 1, minus 4 dot. Even curve B2 is 2 minus 4 minus 3 on mod of 2 minus 4 minus 3, which is 0 minus 4 plus 12 upon root over 16 plus 9 plus 4, which is 8 upon root over 29 units is the shortest distance. Pretty simple to find the shortest distance between two squiare lines. We can observe lines are skew or not by observing V vector for the corresponding lines. Now let us come to next topic, that is parallelepipeds and tetrahedrons. So write down the heading parallelepiped. Let us make a parallelepiped first. So figure, it is a parallelepiped. In this we have to make some points. Point 1 is it is a prism whose base is a parallelogram. Point number 2, it has 6 parallelogram faces. Number 3, it has 4 body diagonals and 12 side diagonals, which are also called face diagonals. Point number 4, the point where all body diagonals intersect is called centroid of parallelepiped. Point number 5, it has 6 pairs of opposite edges. Point number 6 is centroid is a point of concurrency of all body diagonals, and also centroid bisect body diagonals. Centroid bisects body diagonals. Now what I am saying in point 5, point 6, let us understand. There are 4 body diagonals. One is OF, one is BD, one is CG, and one is EA. Okay, they meet at a single point called centroid, and this point, say this is G. Now I have to prove that this centroid also bisect body diagonals. So let's say this A position vector of A is A vector, position vector of B is B vector, and position vector of C is C vector. Okay, so position vector of T will become A vector plus C vector, right? Now what I have to prove? I have to prove that this in point of intersection is point of concurrency, basically, with the help of this statement that uh, centroid bisect body diagonals. So now position vector of O is O means null vector. Also position vector of G will be A vector plus B vector, right? Now proof: if it is O is having O null vector as a position vector, F OF is one body diagonal, sorry. So F is A vector plus B vector plus C vector, right? So midpoint of OF, say G, and using midpoint formula we can get position vector of G is A vector plus B vector plus C vector by 2. Now also other body diagonal is one of the body diagonals is OF and other body diagonal is CG. So C having position vector as C and G having position vector as A plus B. Again, if I am saying midpoint of CG, okay, sorry, GG 2 times हो गया. Say this is not G, this is a H. Timing this is H, and say midpoint of CG is H dash. Again, using midpoint formula, H dash becomes A plus B plus C by 2. So we can see H and H dash are identical. It implies what? It implies point of intersection is point of concurrency. So body diagonals intersect at the same point H. Okay. Point number 7 is the line joining midpoint of opposite edges intersect at centroid. Also, line joining the midpoints of opposite edges means if I am joining midpoint of BE and AD and CE and EG, then they will also meet at centroid of the parallelepiped. Okay, so these 7 points were to be discussed in this parallelepiped. Now let us come to next uh, point, that is tetrahedron. Let us write down the heading tetrahedron. Let us draw its figure first. Let's say ABCD is a tetrahedron. Now in this we have to make some points. Okay, point number 1 is it is a pyramid. It is a pyramid whose base is a triangle. Point number 2, it has 4 triangular faces. Point number 3 is it has 3 pairs of opposite edges. That is, opposite edges are in this case AB, CD and BD, AC and BC, AB, ED. Right? Point number 4 is if we join vertex and centroid of opposite face, the lines intersect at a point called centroid of the tetrahedron, denoted by G. And the G is E vector plus B vector plus C vector plus D vector by 4, where A, B, C, D vectors are the position vectors of the vertices of a tetrahedron. And in this case, say here is A vector, this is B vector, this is C vector, and this is D vector. Okay. Also, point number 5 is if we join the midpoints of opposite edges, then point of intersection is also the centroid. Okay. Now let us take a question based on tetrahedron. Question is, find in radius small r and circumradius capital R of the inscribed and circumscribed sphere in a regular tetrahedron of side K. Students, regular tetrahedron is nothing but a tetrahedron having all equal edges. Let us draw the figure which is according to the question. Students, this green color represents a regular tetrahedron. This yellow color represents a sphere or circumscribed sphere, and white color represents inscribed sphere. Okay. Let's say this inscribed sphere touching all the edges or all the faces, not edges, all the faces at this point. at these points. Okay, now according to question, let's say for the sake of calculation, I'm taking position vector of A as null vector. Position vector of B is B vector. Position vector of C is C vector, and position vector of D is D vector. As we know, centroid is the center for inscribed and circumscribed spheres, both these spheres. So let's say this is G, and also G1, G2, G3 are the G1, G2, G3, G4 are the centroids of the faces or triangular faces at which inscribed sphere is touching. Now it is given that all sides are equal and having magnitude k. So this will be k, or AD will be k, AB will be k, AC will be k. Now as we know, centroid is in this case O plus 0 plus B plus C plus D by 4, that is B vector plus C vector plus D vector by 4, and circumradius is mod of A G vector, which is circumradius, which will be mod of B vector plus C vector plus D vector by 4. Now mod of B vector plus C vector plus D vector whole square is mod of B vector square plus mod of C vector square plus mod of D vector square plus 2 B dot C plus 2 C dot D plus 2 D dot B. Mod of B, mod of C, mod of D is nothing but K. So this will be 3K square plus B dot C dot D, D dot B is BC cos theta. Theta is the angle between B and C, and in regular tetrahedron, theta is pi by 3 because all faces are equilateral triangle. So this will be 2 common BC, that is K square cos pi by 3. So this will be 3 times. This will become 3K square cos pi by 3, which is 3K square plus 2 into 3K square into 1 by 2. So this will be 6K square. So therefore mod of AG vector is root mod of B plus C plus D by 4, and this will be root 6K by 4 units. Okay, from radius. Now in radius, which can be taken as GG1 or GG2 or GG3 or GG4. This is G4. G3 is the centroid for triangle BCD, and this is in radius GG3. This will be B plus C plus D by 3. By taking LCM, this will become 1 by 12 times mod of B plus C plus D by 12. And we know very well modulus of b plus c plus d in previous case root 6 k by 4, sorry, root 6k. So mod of GG3 is root 6k by 12 units. For this class, this was all about. Let's meet in next class. Till then, bye bye and take care.